Hello guys, welcome back to the channel. My name is Gift. Uh, if you are new, please like, share, and subscribe. So, for in this video, I'll be focusing on nature of roots. Nature of roots. So, nature of roots. It is just a way of describing the x-intercepts of a certain function. But most of the time we'll focus on the quadratic function. Let's start with the quadratic function, then we will check other situations as we go on. So let me first write a general equation for a quadratic formula. Then there's something called discriminant. Represented by this sign. So this is discriminant. So even discriminant, we use it to describe nature of roots. There are two ways in which we will describe nature of roots, either by using the discriminant or looking at the function, at the shape of the function, the behavior of the function, looking at it. So let me start by the first function. So the first function is this one with this as its equation. So first of all, we need to have the values of a, b, and c. So what's the value of a? The value of a, it is the coefficient of x squared, as you can see here. Then b, it is the coefficient of x. Then c, it is the constant. So what is the value of a? The coefficient of x squared, it is 1. And the coefficient of x, it is 0. Why? Because we have something like this. We have something like this. So meaning that b, it is 0, making this whole thing 0. Then we have this. Then c, it is 1. So now let's substitute. Then after substituting, we will talk on it. So b, it is 1. We substitute a. How much is a? A, it is 1. Then c, it is 1. Then when you punch it on your calculator, you get -3. So now we'll talk about a discriminant being negative. So a discriminant being negative, it means there are no real roots. So what does it mean? Roots are the x-intercepts. So as you can see, looking at this like function, it is no x-intercept. So there are no real roots. So when a discriminant, it is negative, less than 0, it means there are no real roots. There are no x-intercepts. As I've already said, the roots are x-intercepts. So this function has no x-intercepts. Keep that in mind. So another way where you can see it, you can see from this. This is the quadratic formula for solving for x-intercepts. For x-intercept. So you can see that this is the same discriminant we're talking about. And you know that anything under a square root, if it is negative, it means that this is a non-real number, making this whole thing non-real. Hence, we are saying there are no real roots. There are no real roots. There are non-real roots. There are no real roots. So that's where this whole thing is coming from. Then now, let's move to the next function. So now we have something like this again. We have something like this. So you can see that there are no roots. There are no roots. There are no x-intercepts. So let's have a value of a. The value of a is -1. Value of b, it is 0. Value of c, it is -1. So let's calculate the discriminant. So punch this whole thing on your calculator. Still you get -3. So there are no real roots. No real roots. There are no real roots. There are no real roots. The same situation as this, the top one. It is just that the other one, it is concave up, the other one, it is concave down, but they have no real roots. And remember that the roots are x-intercepts, so keep that in mind. Also, if we go here, it brings the same effect. It brings the same effect. So you need to really understand where the non-real roots thing comes from. You know that from the number systems, when the number or anything, if there is a negative number, something under a square root, it makes the whole thing a non-real number from the number system. So you need to keep that in mind. Then now let's move to the other example. So now we focus on the function, this one. So its equation, it is just x squared. So this function, let's calculate its discriminant. Firstly, let's find the value of a, it is 1, value of b, it is 0, value of c, it is 0. Then now let's calculate the discriminant. A, it is 1, c, it is 0, then it makes the whole thing 0. So now let's discuss the roots, looking at the behavior of the function. So the function has only one x-intercept. So in other words, it has equal roots. It has 2 roots, but the roots are equal, making 1 root. So there's no difference. So hence, when you're describing the nature of roots, when the discriminant it is 0, you say real. They are real roots because they exist. Real, equal, rational, not really rational. The rational part, we'll discuss it. Real, equal roots. they are real and equal. Even when we go to the quadratic equation, you have something like, then you can see that this is the discriminant. The discriminant is 0. Then we have, so meaning that if the discriminant is 0, then the x-intercepts will be negative b over 2a. So meaning that the x-intercepts, they are the same, because b, it is the same, a, it is the same. So nothing will change the value of x. The value of x will just remain the same, meaning that equal roots, like the roots are equal. Hope it makes sense, just like this. So it is real, equal roots. So if they are non-real, they are real. You must include the real. You must know that if they are non-real, they are real. So include the real, then after real, comment on the equal. If they are not equal, they are unequal. So we need to put that in mind. So even if you get the function that it is like this, still it is the same situation. Real, equal, roots. Then the issue of rational, we will discuss it as we move forward. The issue of rational, we will discuss it when we go forward. Then I will come back on these ones. Then now there is another one. So the equation here, it is here, the equation, it is like this. So now we can see that here there are real and equal. They are unequal. They are unequal. Then the rational part, we'll discuss it. They are real, unequal. Here we'll discuss the rational, irrational point. So now let's decide on the value of a, b, and c. So value of a, it is 1. Then the value of b is 0. The value of c is negative 1. So now let's calculate the discriminant. B is 0. Is b 0. Then a, it is 1. Then c, it is negative 1. Then the discriminant becomes 4, and 4, it is positive. So for positive, in here we discussed discriminant being negative and discriminant being 0. Now we are on the point whereby the discriminant, it is positive. So when the discriminant, it is positive, it is real and equal roots. So that's what you need to know. Then even when we go to when there is something positive here, when there is something positive here, when there is something positive here, the roots become different because the first root will be negative b plus whatever that is here, then the other root will be negative b minus this, and you can see that this is clearly not equal to this. So these roots will be real and unequal, meaning they will be different. This one will be -1 and this one will be 1. So that's what you need to know. Like, if you really understand these things from here, like how to interpret, like, you beef, like, I can say you beef just fine. Now let's go to the roots being rational or irrational. So now for roots to be rational, discriminant must be a square number or square anything. Okay, let me show you how it works. So let's say let me explain rational. So rational numbers, in this case, like, are just numbers that can I say, but you need to refer to the number system. So I need to refer to the number system so that I can be precise. But for the issue of nature of roots, for roots to be rational, the discriminant must be a square number. The discriminant must be a square number. So let me show you how it really affects. So let's say you're solving for this. This is a discriminant. Then the discriminant is 4. 4 is a square number, meaning that this whole thing will be, then this thing will be rational. This thing will be rational. So let me show you what is a rational thing. How do we see rational numbers? So first characteristic, rational number, it is that if the number has a square root, whatever that it is in the square root must be a square number. That's the first characteristic of a rational number. So a second characteristic of rational numbers, it is that they must be able to be written as a fraction. If they can't be written as a fraction, then they are no rational numbers. So for in case 2, if you have 2 can be written as a fraction, which is 2/1 or 4/2. So this is what we mean. Then the other one, it is that it must be an integer. It is that decimal form terminates or repeat. For in case if you have 0.333, this is recurring. Then there is another one which is terminating decimal, for in case 0.25. For example, this 0.25, it can be also 0.2525. So this is one, it is recurring, and this one, it is terminating. So if you really check this one, if it is terminating, it can be written as a fraction. If it is recurring, it can be written as a fraction. If you punch this on a calculator, and press equal to, you get a fraction. So another one is that they can be represented on a number line. So those are the important characteristics of rational numbers. And another thing is that, like, you should know numbers that are non-example, that are irrational. So the first one, irrational numbers. Example of a rational number, it is a pi. Then another one, I've mentioned it. It is a square root which has a non-square number inside of it. So yeah, that's what you should keep in mind. That's all. Thanks for watching. Please like, share, and subscribe for more videos, obviously.